Welcome back. So now it's time for this chapter. And this chapter, as you can see here, is called HCI Mesh using Remote vSAN. So this chapter deals with a brand new feature. And again, the brand new feature is simply called Remote vSAN. What do I mean by that? What I'm talking about is the ability of, in one cluster, mounting the remote vSAN data store belonging to a second one. Now, when you take a look, here again, they're trying to explain to you why this particular topic is very important. Now, let's see what they say. As you can see here, it says, until now, compute and storage have been tied together. You know very well that, again, for the longest time, if you build a vSAN data store, only the members of that cluster could use that vSAN data store. Well, that's no longer the case. Again, now you can mount somebody else's vSAN data store. Now, if you take a look, it says with HCI Mesh or Remote vSAN, call it what you will, you can scale storage and compute independently. Which means, once again, if I need more space, I could now access the data store belonging to a different cluster as long as both clusters are controlled by the same vCenter and they happen to be on the same data center. Now, this chapter has 3 lessons. The first one is simply called HCI Mesh Overview and Use Cases. The second one is the one that shows you how to mount the vSAN data store. And lastly, we talk about how this is or is not compatible with other features of vSphere. So we're going to be talking about the relationship between HCI Mesh and HA, DRS, vMotion, and storage vMotion. So let's start with the first lesson. What I have done here is I have built 2 different clusters. On purpose, I build them a little bit different. There's a reason for that. And again, what I'm going to show you is how I could take the first cluster that I have. He has access to his, obviously, data store. I'm going to show you how now you can say, gee, if you belong to the first cluster, not only you get to see your vSAN data store, but you also get to mount the vSAN data store belonging to my second cluster. And the first cluster can mount the vSAN data store belonging to the second, just like the second can also mount the one for the first. So here we see the goals of this first lesson. So instead of reading all these particular bullets, again, all I want to do is talk about what this is, what it brings to the table, do's and don'ts, best practices, and so on. So let's start with this page. Again, here, you can see the page says Introducing HCI Mesh. So once again, this is a brand new feature. And a lot of people have been asking for this. Once again, a lot of people have been asking, how is it that you can only have one vSAN data store per cluster? Now, that's no longer the case. Because again, you can have yours. And you could also access somebody else's. So when you take a look, here it says with the HCI Mesh architecture, you can remotely mount data stores from other vSAN clusters. These would be the server clusters to one or more vSAN clusters. Those would be the client ones. So in my analogy before, if I take cluster 1 and I mount the vSAN data store belonging to cluster 2, cluster 1 here is the client cluster, and cluster 2 is the server cluster. Now, when you take a look, for years, people have been asking for this feature. Because think about it. When you build, let's say, X number of clusters, what happens sometimes is that you end up with one cluster that is running out of space and the other one that is not. So that's what they're showing you here. Here again, they're showing you that you have the first cluster. He is at 40% capacity. Yet the second one has reached 80%. So let's break this down. Before 7.0 Update 1, if that happened, remember the servers on the second cluster could not access the vSAN data store of the first, but now they can. So what I could do is I could storage vMotion some of the VMs from the second cluster into the data store of the first cluster while they're using CPU and memory on the second one. And again, balance space between the two vSAN data stores. So you no longer waste resources like you used to in the past. And if you take a look, here we talk about the advantages of HCI mesh, and there are plenty. I mean, think of the possibilities. A minute ago, I mentioned that you could storage vMotion the VMs to balance space. But think about other possibilities. For example, let's say you want to do maintenance when it comes to the disks of the first vSAN data store, while the VMs are using CPU memory on that cluster. Temporarily, those VMs could be using space somewhere else. So if you take a look, number one, it improves the storage to compute ratio. Number two, notice they mention license optimization. Number three, heterogeneous storage classes. One of the cool things, and I love that, one of the cool things about this feature is that I could have two, for example, clusters. Maybe one is using, let's say, NVMe devices. Let's say another one is using SSD devices. Can I mount the vSAN data store belonging to the other cluster if the disks are different? The answer is yes. So again, then I could choose, for example, where to store my critical VMs, where to store my secondary VMs. And again, I could mix and match different types of disks, not just NVMe with SSDs, but also what about magnetic drives? Yes, you can. So that's pretty slick. And when you look again at this example, here you can see you have three clusters altogether. This is what they call a vSAN cluster federation. And again, you can see that the second cluster is overused. So notice carefully in this drawing, in the second cluster, you have 4 VMs running. 2 are used in the local data store, and the other 2 are using remote vSAN data stores. Now, when you take a look at this page, in this page and the next page, we talk about use cases. So, once again, you got to think of the possibilities. And if you look at the first one, we've already mentioned that. You can balance capacity across vSAN clusters. Notice it says HCI mesh can be used for balancing capacity. That probably would be the most common reason to use this. Once again, you realize that you're running out of space in one, mount the remote vSAN data store. It takes about a minute. And then at that point, just storage vMotion your VMs. But what about hardware maintenance? Once again, imagine that in the first cluster, you decide to enable a feature that perhaps will require a DFC. Typically, you're talking about moving data around. In this case, what you could do is simply just storage vMotion all the VMs out of there. And then again, without having to worry about taking chances in absent components, you could again perform the DFC safely. And if you take a look, bullet number 3, this is the one dealing with storage as a service. So again, you could mix and match different types of data stores. One could be all flash. One could be based on magnetic drives, aka the hybrid architecture. And then you decide where to place the different VMs, depending, of course, of the needs that they have. And if you take a look here, they continue talking about the reasons to use HCI mesh. So notice, scaling compute without adding storage. And if you take a look, it says traditional vSAN scales by adding hosts. Remember, that is scaling out. And again, that may not be what you want. So notice it says you may end up with too much storage because of that. In the past, again, you'd be wasting that storage. So again, think about it. Maybe you just need more CPU and memory, but you don't necessarily need more space. Right? So again, think of all the possibilities out there. And if you take a look, it says you can use HCI mesh to scale storage and compute independently of each other. Technically, you could even build clusters without a local vSAN data store. And again, they just mount the remote vSAN data stores. And we've already talked about how you can save money because of license combinations. Now, the main thing here is stranded capacity. Once again, we're not wasting resources like perhaps you were doing in the past. So here it says a fixed compute to storage ratio can lead to a stranded capacity problem. So once again, in this case, you could repurpose, if you will, that space that otherwise it would go to waste. And when you take a look, we've already talked about this. So imagine if I have 3 clusters and I want to mount all the vSAN data stores in all the clusters. This gives me complete flexibility. So now imagine that I have a different type of workloads. On one hand, maybe a database. Maybe on the other one, maybe, I don't know, let's say some kind of Apache server. I'm talking about something like a web server. They have different requirements. So like to tell you here in the book, maybe you have an Oracle database. Maybe you have an SQL server. You want to put those type of VMs and the fastest storage. Having said that, when it comes to a web server, maybe you don't need NVMe devices for that. Maybe you don't even need SSDs. Maybe again, you're just happy by putting those VMs in your hybrid architecture. Or again, perhaps you put your test VMs in the hybrid architecture and your prod VMs in your faster storage. So when you take a look, here you have a scenario where you have 3 clusters. And as you can see here, everybody's running VMs. Some of them are local, some of them are remote. Take a look at the cluster on the bottom left. He has 4 VMs. 2 reside in the local vSAN data store. Another 2 happen to be running on that cluster, yet the objects happen to be on the other vSAN data store. The second cluster, once again, has 4 VMs. Notice the fourth one. The fourth one is running on the second cluster, yet it resides on the third vSAN data store, and so on. And if you think about it, over the next few pages, what we have is terminology. So notice here they mention local cluster, server cluster. And if you take a look at the next page, the concept of the local vSAN data store, the concept of the remote vSAN data store, and the concept of cross-cluster vMotion. So if I'm a member of cluster 1, if I have my VM in my local vSAN data store, that would be what? Local vSAN data store. If I store vMotion that to the second data store, to the one belonging to the other cluster, that would be an example of a remote vSAN data store. And remember, in that case, I am the client. The cluster that controls the second data store, he happens to be the server. Now, when you take a look, here over the next few pages, I show you examples of your type of architecture. So here they mention cross-cluster topology, and they also mention storage-only cluster topology. So the idea here is what? I can mount yours, you can mount somebody else's, or I can mount yours, and you can mount mine. So that's what I currently have. So let's take a look at this illustration. Now, if you take a look here, we have 4 clusters. Notice, the first cluster, the one on the upper left, he has a local vSAN data store, but he also mounted a remote vSAN data store belonging to the cluster in the bottom. If you look carefully, the middle cluster at the top, he only has a remote vSAN data store. So in that case, remember, you could technically have a cluster without a local data store because maybe you don't want to use more disks. Maybe you don't need that because you have extra capacity elsewhere. So again, think of, once again, the possibilities. And if you take a look, here you have an example of a cross-cluster topology. Once again, here I have mine, I mount yours, and you have yours, and you mount mine. Notice, everybody's mounting pretty much everybody's. Now, right now, this is what I currently have in my setup, and I'm going to show you that in a second. So when you take a look at the requirements, here they mention network connectivity requirements and also latency requirements. Let's take a look. When it comes to network connectivity requirements, take a look at bullet number 1. Notice it says both layer 2 and layer 3 are supported for inter-cluster connectivity. If you take a look at the rest of the page, notice it says network redundancy recommendations. You know very well that we always recommend redundancy everywhere. And notice they mention top of the rack switches. If you take a look, here notice at the bottom, they talk about network performance requirements. An HCI mesh has the same requirements for remote vSAN data stores as if it has for local vSAN data stores. Here you have an illustration where you can see the top of the rack switches. And again, we have different pages to deal with. So here again, we're talking about licensing. So when it comes to this, I've mentioned, right, that I can mount your vSAN data store, you can mount mine. But you probably know that we offer different licenses when it comes to virtual SAN. Notice at the very top, we tell you what license you need. And it says vSAN Enterprise Edition is required on all the clusters participating in a mesh topology. At the bottom of the page, they also tell you that a client cluster can mount a maximum of 5 remote vSAN data stores. And if you take a look, that concludes lesson number 1. Now, what I'm going to do here is I am going to show you what I currently have. And again, in my setup currently, I have 2 clusters, a 5-node cluster, a 3-node cluster, and I have mounted the remote vSAN data store in both cases. So let's take a look. Thank you, and I'll see you when I do my little demo.